Hi, welcome to this conundrum. Is it true what it shows on the screen, that 9.999 going on forever is equal to 10? At first you might say no, but let's look at the evidence. In fact, the answer can be yes and no, depending on which way you look at the situation. Let's call the infinite decimal by the letter n, and we'll call all of that equation 1. We'll now multiply both sides of the equation by 10, so 10 times n on the left, and 10 times 9.999 and so on will give us 99.999 and so on, simply by moving the decimal point one space to the right. Now we'll subtract equation 1 from equation 2, and that's what it looks like. On the left, 10 times n minus 1 times n gives us 9n, and on the right, the decimal parts of each decimal cancel, and we're left with 99 minus 9, which is 90. Now what does that mean? It means 9 times something equals 90, so n will be 90 divided by 9, which is 10. So we started with saying n is 9.999 ad infinitum, and we ended up by finding that n equals 10. Contradiction? Let's move on. Here's another way of looking at the situation. Let's split up the number into 9 plus the decimal part, so n will be 9 plus 0.999 going on forever. The decimal part we'll call m, and what we will do is exactly what we did in the previous part. We're going to work out what m is by multiplying and subtracting one equation from the other. So multiply both sides by 10, subtract the first equation from the second. On the left, 10m minus 1m is 9m, and on the right, the decimal parts cancel. So we have remaining 9m equals 9. So m will be 9 divided by 9, which is 1. Now we've said that n is 9 plus m, so if m is 1, n will be 9 plus 1, which is 10. Is this a contradiction? Let's move on. Alright, here's another way of splitting up the decimal into a whole number part, the 9, plus the decimal parts. In other words, we split up the 0.999 and so on into the sum of decimals. Can you see why that's the case? What's happening to the decimals? The decimal parts are in fact the terms of an infinite geometric series. That means each term is obtained by multiplying the previous term by a fixed amount called the common ratio. And we have a formula that gives us the infinite sum of a geometric series, and there it is. S infinity equals a over 1 minus r, where a is the first term and r is the common ratio. Just as an example, let's apply that formula to this geometric series. 1 plus a half plus a quarter and so on. For this one, a is 1, that's the first term, and r is a half because we multiply each term by a half to get the next term. Now we substitute those values into our formula, and as you can see, the infinite sum is equal to 2. That means, of course, that if you add those terms to infinity, it comes out to be 2. But the question is, what does to infinity mean? Can we actually ever get there? Now apply that formula to our series. A is 0.9, the first term. The common ratio is 1 over 10, or 0.1 as a decimal. Substitute into our formula, and we end up getting that the infinite sum is equal to 1. Now we've said at the beginning that 9.99 and so on is equal to 9 plus the infinite geometric series, which equals 1, so our final answer will be 9 plus 1, which is 10. Again, is this a contradiction? So what can we conclude? Does that infinite decimal equal 10? The answer is yes, if you think of 9.99 and so on as the infinite sum of terms of a geometric sequence. But the answer is no if you only take a fixed number of decimal places. Plenty of food for thought. Until next time, bye-bye.